This is a review of the ESRI e-learning course Image Processing with ArcGIS. The role of imagery in this course is to process and analyze digital images collected mainly from satellites. So images and rasters are used in ArcGIS for a variety of reasons: as a background to provide reference to geographic data, for heads-up digitizing while editing, for visually interpreting a site, and for advanced analysis. Why do we do image processing? It can make imagery more useful and informative by analyzing the data that is inherent in the imagery. We can answer scientific questions. And using image processing techniques allows you to extract information for use in analysis. ArcGIS offers many options for image processing. The types of spatial analysis that you will learn about in this e-learning course are composite images, which are a combination of red, green, and blue bands to form a true color image, as you see here. Hillshade, which is taking elevation data and applying a tool to it to make it represent what the real world actually looks like, as you can see in the middle image. NDVI is Normalized Difference Vegetation Index, and it's a relative measurement of relative greenness based on biomass. So the example shown here has a black and white image, and then on the right you can see in shades of green and purple the results of NDVI. And finally, pan sharpening, and that's where you take high resolution and low resolution multiband image, and the high resolution image has the capabilities of multiband imagery as a result. And so that's what we call a pan sharpened color image. A little bit more about NDVI. You can see here a representation of the equation for NDVI. It is the difference from the near infrared band minus the red band divided by the near infrared band plus the red band. And the values vary between -1 and +1. It is an index, so it is unitless. If there is more reflected radiation in the near infrared wavelengths than in the visible wavelengths, then the vegetation in that pixel is likely to be dense and may contain some type of forest. And the image here of leaves is showing a healthy plant on the left with an NDVI of 0.72, and on the right is a non-healthy plant showing an NDVI of 0.14. So non-healthy plants can be plants that are in the senescence or falling off period or the browning up of leaves. It can also be plants that are water stressed. It can be plants that have been impacted by viruses or pest invasions or things like that. And so you can see the relative percentages there of the near infrared and the red with the healthy green leaves, 50% near infrared, 8% red, and then with the unhealthy leaves, 40% near infrared and 30% red, and that's referring to the reflectance in those bands. So understanding NDVI science, again, it is a measurement of looking at the different reflectance within the portion of the electromagnetic spectrum that we call near infrared and red, and it gives a value on each area of the image, and it helps identify varying levels of plant vigor, and this is correlated with the health of the vegetation in terms of the amount of chlorophyll in the leaves. So a plant with more chlorophyll is more photosynthetically active. In this image here it is shown as more green, and a plant that has less chlorophyll is less photosynthetically active. This is an example of a MODIS composite taken from 16 days of images, and it is in the Alps. and the composite helps with errors. So in satellite images, you will have errors because of atmospheric gases, water vapor, etc., and clouds. And so the advantage of taking a composite of multiple days is that you reduce the overall error in your index analysis. And the disadvantage is that you do lose details. So NDVI and EVI is Enhanced Vegetation Index, and they are used as indicators of drought. They're used to monitor crop health, and they are also used to detect disease outbreaks and insect infestations. Here's an example of 3 imagery types that are used in image processing. So on the left is an example of aerial imagery, in the middle is satellite imagery, and on the right is a derived product that was created with ArcGIS, and it is a digital elevation model, which is symbolized DEM. So in this tutorial from ESRI, you will be enhancing image displays. The contrast function adjusts contrast to allow objects to stand out. So in the top image, you can see that there is a difference in the appearance of some of the objects in that image. And this may be intuitive to you, but one thing to keep in mind is that urban structures or man-made structures tend to be very geometric in shape, regular lines, polygons, rectangles that represent buildings, crop fields, etc., whereas natural features tend to be more irregular in shape. So moving on down to the middle, we have brightness, and you can adjust your image display brightness to give you a fuller or narrower range of brightness values. And then finally, transparency allows for viewing of layers underneath. And in this example, once the transparency is set on the green and yellow image on the left, you can see more features of the hillshade that show up in the image on the right, which gives more of a representation of the real world. So gamma refers to the degree of contrast in raster images, and it adjusts mid-level gray values. It doesn't have any effect on the black and white. DRA stands for dynamic range adjustment. It balances the bright and dark areas of an image based on data in the image. You're not changing the data itself, you're just making more balance between bright and dark areas so they features appear more readily. With stretch, what you're doing is you are broadening your range of digital numbers to change the image viewing. The different types of stretch that you'll work with are none, min, max, standard deviation, histogram equalization, percent clip, and an ESRI stretch. When you resample, you're interpolating the pixel values to fit your raster dataset to the desired nearest neighbor by linear, cubic convolution, and/or majority. So an interpolation is a way of filling in gaps or spaces in the data and providing a smoother output. The skills that you'll cover in these exercises are access a mosaic dataset, access and enhance imagery, create an NDVI, use pan sharpening to improve the quality of an image, and apply a hillshade to an image.